Hello game makers, this is GameMaker Rob, and in today's episode we have a world map. We're able to move around, the character will face the correct direction. We also have the ability to use animated sprites, although I don't have any of my own, but if you have your own, it's now very easy to use them. So let's get started. Okay, so as you can see, we have a world map. We're going to have a couple of places you can visit, dictated by these different objects. It doesn't matter how you make the world map. You can use tiles like I did, or just have a background. The main thing on here is going to be these instances of world points that we use. So the first thing you want to do is make a new room and call it rm_world_map, and then we want to make an object called obj world point. Let me just actually show you the sprites for that. So we have the normal path point, and then another path point for when it's being selected by the mouse, and also if the player can travel to there from his current location, it'll show up. If you just mouse over any path point, it may not show up because we only want it to display if the character can actually move there. So add the sprite to the object, and we just want to set the image speed inside the create event of our new object to 0, just so it doesn't animate between these two images like that. And then in our new room, you can place them anywhere you like. The way the code is going to work, as you can see in the intro, is the player will change facing based on where he is and just walk between whatever points we allow them to. How we are going to decide where the player can walk to and from is dictated in the creation code of each instance. So if you double click, this box comes up and you click on creation code. So we're going to add this to every individual instance of obj world point. This first variable is going to be unique for each instance, and so this one is path point 0, this is 1, 2 and 3, and connect to is going to be a list which is going to hold the path points that this one can connect to, and this line here is going to add the path points that it can connect to the list. So this first location can only connect to 1, which is here. If we open the creation code, you can see path point equals 1, and this one here has 2 locations. It can connect to 0 and 2. 0 is here and 2 is here, and then this creation code, we set this to 2, make the list, we tell it can connect to 1 and 3, which is here and here, and then the final area is path point 3, make a list, it only connects to 2, like so. I kind of skimmed over the room creation. All I'm doing for now is I've got the width of 480, width 480, height of 270, and the viewport 0 is 480 by 270, and then we double it for the port, which is the same as every other room that we've got. So we're just keeping the same dimensions. There's nothing stopping you adding some kind of camera so you can move around the map like we do in the editor. For this example, for this tutorial, I'm just going to have a single screen world map though. Okay, the next thing I want to show you is I mentioned in a previous video where I wanted to allow for people to have animated sprites based on different states. The way I had the sprite set up initially wasn't really convenient for that. and it would mean you had to change things yourselves. So what I've done is I've organized the sprites, and I have created a for loop which will, first of all, well, it does one thing. It basically adds the sprites in the correct order into a grid. I'll show you this in a minute. So each of these groups holds sprites for the relevant character. So if we open Fighter, he has his idle sprites, west, north, east, south. There's only one image in each sprite. That's just because I don't have any animations ready. There's nothing stopping you, and the idea of this really is for you to have an animation for idle west, an animation for idle north, animation for idle east, an animation for idle south, and then you could have the same for walking, attacking, that kind of stuff. This is how we're going to need to set it out. The order in which these sprites are in is also very important. They're all west, north, east, south, and the classes are all in the same order as they appear in the enumerator. And if don't forget that, let's just go to main. Don't forget that we have the very first value is leave empty. So we need to account for that by having this one here. We don't use actors, just like a default. We don't really use it in the game apart from the editor. But it's useful to have it here to fill in the gap here. And then we have Fighter, Archer, Mage, Priest. You can see they're in the same order. And there are no other sprites before this one here. In case you don't know, if you do show debug message string SBR isoactor IW, it'll return a value of 0 because the way GameMaker reads the sprites is as numbers, and numbers are assigned based on where they are in the tree. So this one will be 0, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, and so on. That's how the sprite resources are going to be filled. So we had two options. We could either do this like times 4, or we can use a for loop like this that just does all the work for us because we've organized the sprites. So I'm just going to delete this because we don't need this anymore. We're in the create event of obj main, by the way. So that was our previous code. This code here does all the work for us. I also changed stationary to idle because it's less letters, it's easier to type and stuff. Global.car Sprite Grids is going to be a list that holds a grid for every character, and every character's grid is going to hold all the sprites for that particular character for all the states. It's similar to our battle map list, where the list holds grids, where it holds strings, that kind of thing. We're just doing the same thing, but we're holding a grid for each character in the list. Sprite count. If you remember, I was saying that this sprite is 0, this is 1, 2, 3. We need some kind of counter for our for loop that's going to go up by 1 for every sprite, and this is what we're going to use for that. So this for loop, this one here, is going to go from character 0, which is actor, the leave empty one, all the way up to character last, which is going to be Davos. That's going to be the last one that goes in. We're going to create a grid for every character, and then for every direction, so these 4 directions per state, we want to add a sprite to their grid. That's what this does. And then as soon as we've added a sprite to the grid, we increase sprite count, and that keeps us moving along the list. And then after this for loop is done, it's going to have added every sprite for this character. So then we want to save that grid, that character's grid, into our list. So that's what all this is doing. Make sure you read these notes here. So like I said, if the sprites are not in the correct order in the resource list, they won't be added in the correct order. So having them like this is very important. You can just ignore this. You can just do it the old way, where you do every line, but this kind of game with this many sprites, I think a for loop and organized tree is a better way of doing it, as long as you know what you're doing. And like I said, don't forget to use placeholders for leave empty. For every state we have, we're going to need sprites for this guy as well, even if it's just an empty sprite. That's fine. We also need to go into the states region for the create event of obj main. And we want to add game here. And we want to set game state to game. And we want to say if game state equals game, then go to the world map. Okay, because we've made these changes to the sprite setup grid, should be grids now really. Because we've done that, we have to do a few modifications to our other objects. So in OBJ editor, there's nothing to change in the create event. In the step event, so in paint the map, place unit spawn tile, this one here, where we are checking the mouse sprite. This was our original line. This is the new one. We're just changing SBR ISO actor into this basically. That's all we did there. Then I think that's it for this region. And then rotate the unit. Okay, so this was our previous code. This is the new code that does the same thing. So we have to change the name of the sprite. This only changed because each sprite only has one index, when before it had 4. So now we're just going to type 4 instead of this. That's it. Then this was our previous code for mouse wheel up rotating. Same thing, just changing the name here. And this becomes 3 as opposed to get number -1. That's that region done. And then we can go into the draw event. So previously we just had this line here because we could grab the sprite directly from our single grid. We only had one grid that had all the sprites for the characters, but now we have a list of grids. So we first of all need to get the grid for the particular character, which is the unit. Whatever unit equals 1, 2, 3, 4, that's going to be the character. So that's the character grid we're going to get from that position. And then we need to find the particular sprite for the particular state for the particular facing of that character, and that's going to return the correct sprite as long as these are in the correct order. It'll work. And then this was our previous line. We had to draw the unit facing. That was going to be our image index. But now, because we've already got the correct facing, because it's a sprite, we just have to draw this. If you're wondering about how to animate things, we would have a value instead of 0, and that would be our image index that would change every step. In the battle, when we get to battles, I'll just have objects as units, and we'll just be using the object image index to draw. But for the editor, we're just going to have stationary sprites. I don't think that's a big deal for the editor. That's going to be it for the draw event. And then draw GUI. So these are our previous lines for width and height. We're just changing the name of the sprite. Same thing here. Same thing here. And same thing here really. Yeah, just changing the name of the sprite really. That's all we had to do. And that's it for OBJ editor. And now we have to also update the draw event of the test object. It's just basically the same thing that we've done before. Changing this to grabbing the grid and then getting the sprite from the correct grid. And then here we don't need facings, we're just going to have type 0 instead. And then this one here, we just change the name of the sprite. That should be it for the test object. Yeah, awesome. Okay, so now we actually want to create a player object. So this guy here, I've given him just the east facing of the butts character. And once you have made the object, we're going to drag him into the world. We're going to place him in the world on the first. Let's get rid of this snap. So about there looks good. There we go. So he's on the first marker. We're going to have him walking across the world very soon. We're going to place the player here, and all we're going to have for this episode is moving around from point to point. In a future episode, we're going to have we're going to launch battles from these points, as well as the ability to go to a shop and buy items, as well as going to just a location to have like a cutscene to progress the story. But for now, we're just going to move point to point. So to facilitate that, if you go into the create event, we've got some states for the player: init, idle, and walking. Why do we have init? It's shorthand for initialization. This is because I want to have some code run on the first step that happens after the create event, because I need to store all of the path points that are in each of these. I need to store the IDs and their path points in an array for the player so he knows where to go to. It'll make more sense in a minute, but we're going to first initialize the player to do that and then set it to idle. Walking equals false. We don't want the player to be able to do things whilst he's moving from point to point. And we don't want to display certain things while he's moving from point to point. So this boolean is going to dictate that. Path point. This is the current path point that the player is standing on. We're going to set it to no one because it's going to store the ID of the path point that the player is standing on at the moment. And then this grid is basically the grid for the butts character, because we're going to use that to draw his sprites. Again, you can use animated sprites, it'll work fine because we've got an object. We can use the object's image index to draw himself. So now if we go into the step event, so let's make this a region. Let's make it a bit more clearer. Bear with me a minute, sorry. Okay. So we've got region init, idle, and walking. So in initialization. Okay, so this code here, we're going to be creating an array inside the player via this with loop. And in the array, it's going to store the IDs of every single one of these path points. And the ID is going to be stored in the correct entry based on its path point. So for example, this first one here, is path point 0, so its ID is going to be stored here, and then this second one, its ID is going to be stored here because it's going to be stored in entry 1 because its path point is 1. And then I'm sure you can see where this is going. The last one is going to be stored in path point 3, entry 3. Now, the good thing about this, it doesn't matter what order we put down the path points in the world, because as long as each one has its own unique path point number, and we've said we've done the creation code correctly, adding the path points it can connect to, as long as we've done that, then the for loop will just add them automatically into the correct slot. And the good thing about arrays is you can just do this. You can just create an array while adding something to it, and it doesn't even matter if the first instance had the last entry, because the other preceding entries will just have an arbitrary value added to them anyway, and then those arbitrary values would get overwritten by the subsequent instances of OBJ world point. So this does a lot in one line, basically. So now we've created an array in the player. The player can access path array for everything else that it needs. The next thing we want to do in initialization is check which path point we're on. So path point equals collision point XY OBJ world point. That's going to return an ID. This is just for debugging. We don't need it apart from that, but it's nice to see that it works. And then we're going to set the player state to idle, which is the default state. So in this state, we can decide where to move to. We also want to make sure that all the world points have their indexes set to 0. The reason that is because we're going to be changing one of them, maybe to the second index, which is this one here. If we move a mouse over one of the path points and we can move to it, it's going to change to this one from here. But we have to also reset the path point after we move the mouse away. So rather than doing a check for every instance to see, oh well, has the mouse moved away from you, it's just easier to reset all of their indexes to 0 in the first place and then check for the mouse. So every step, every one of these path points gets their index set to 0. Then we check for the mouse. Mouse over path is going to hold an ID or no one. So if the mouse is over something, one of these path points, and the path point of this particular world point is in the list of the path point that the player is standing on. So basically, if we move the mouse over here, it's got a path point of 1, and then we're checking the list of this path point because the player is standing on it. We're checking this list. Does it contain 1? Yes, it does. Well, then we're going to change this guy's index to the second index. If we move the mouse over here, it's got a path point of 2. So we check the list of the first world point. Does it have a number 2 in its connects to list? No, it doesn't. So it's going to return -1. So if that path point is in the list, it won't return -1. If it's not in the list, it'll return -1. So as long as we're moving over a point and it's something we can move to. Changes index to 1. Inside this as well, we want to check for a mouse click because we want to see if the player actually wants to move there. If he does, we're going to use move towards point, very basic movement, and set the state to walking. So this code here is going to basically determine the sprite for the player. dir direction is going to get the direction from the player to where he's moving to. It's going to be a value from 0 to 359, I believe. This will show you what dir equals in the output. Just useful to test it. So all we're doing is 4 checks. I couldn't think of any clever way to do it without reorganizing the facings, so I've just done it on a per facing basis. It's just checking to see whether this value here, this variable, is within a range of 2 numbers, and set the sprite to whatever is stored for that particular facing. This is how GameMaker works out the angle. So it's to the right is 0 degrees, and then it works on anti-clockwise. So it goes from 0 to 90, then 90 to 180, and 180 to 270. A little bit counterintuitive, but that's why it's good to know how this works. This is wrong, by the way. This was when I forgot how this worked, so I'm going to delete that. Then in a walking state, we just want to check to see if the player is getting to his target. So ABS of x minus mouse over path.x. If it's less than or equal to 1, and also the y is less than or equal to 1, after we've done the ABS on this, if the difference between where the player is and where he's getting to is 1 pixel, then set his speed to 0, get the new path point, and set his state back to idle. So now in the draw event, we just want to draw the character, and also we want to display to the player where he can actually move. I'm just going to use red lines for this because, again, this is a tutorial. So this for loop is going to run through the list of the current path point. We're checking that the path point isn't no one, otherwise it would give us a crash if we try to do this. So if the list only has 1 path point, this is only going to run once. If it has more than 1, it'll run that many times. So we're going to grab each path point in turn. It's going to be 0, 1, 2, 3, etc., etc. And then we're going to find which ID that path point relates to, which is stored in our player's path array. So now connecting ID is going to store the ID of these world points, basically. That's what it's going to do. And then we just draw a line from the current path point the player's on to any connections the player can get to, just so the player knows where they can go. So I think we can run the game now. So I discovered I did actually get a crash. Well, not straight away. I had a problem with my project. Basically, what was happening is path point wasn't. It was set to no one, and it wasn't detecting any path point at the start of the game. This is because I had my collision mask like over here somewhere. Easy mistake to make. I've done that kind of thing many times. So once I had it over here, it worked fine. But I did add, just for debugging purposes, I had added this line here so I could see the value of path point. So if you run the game, so cool. If you move the mouse over this first path point, you can see the arrow shows, displays. If we move it over this one, then it doesn't display because you can't move there directly from here. So let's try and see if the movement works. It does. Awesome. Can we move to this one and this one? Yes, we can. Let's move back to the start. You can see the facing matches the direction he's moving in. There we go. So I'm just going to try and click around stuff to see if there's any bugs in the code, but it seems like it's working pretty well. Thank you for watching, and like I said, I'm going to try and get some in next episode. We're going to have transitioning from the world map to other maps, and we can see our game start to take shape. So pretty excited for that, and I hope you are too. I will catch you next time. Bye for now.